So we will see what actually is particles. See what is actually made of particles. See whatever we see around us actually, like see this marker. There are different objects, right? Actually, there are different objects that we can see around. See the marker, or maybe this ring, the ring which we wear on the hand, or like there are. Of course, there is this liquid, actually what we uses for cleaning the board. Okay, and maybe of course there is gas. Gas is surrounded by surrounding our atmosphere, right? So one thing actually what is common with all these things is actually even solid or gas or liquid, all these things it is made with the particles. So let's consider actually. So there is a brick, right? Actually this could be a brick. So and even this brick it is made with the particles. So if you take this liquid actually, or even gases, okay, liquid actually you see like this. See, I am taking this solid. This is nothing but a solid, right? So I am moving. Actually, these particles which is made on the surface of this marker, it is not moving. So, and here actually on the other hand, when I am shaking, okay, so you can see this, the particles are moving. What it means is, these liquid particles, it is always in zigzag motion, okay. So it is in zigzag motion actually, like, what to say, it is, how these particles it is moving actually. See, suppose you consider a beaker. So there is of course enough amount of liquid, okay, and if you see this, if you enlarge and see this, okay, these liquid particles, it is always in motion. It is always in actually, okay, this will be moving here, this will be moving here, this will be moving here, this will be moving, this will be moving, this will be moving, and this will be moving. Always it is in constant motion. What we call it as random motion. Actually, or else you can also call it as a zigzag motion. Zigzag motion is, like some newborn babies. The babies, you cannot see them there, right? Actually, they will be moving here, they will be moving here, they will be moving, they will be moving, they will be always in a random motion. The things will be moving. Okay? So that is actually the particles. Actually, the particles, it is always for a solid. Of course, it is in actually, what to say? It try to remain as a, it will try to remain in one place. But for liquid and gases, even the gases actually, it goes in an even more faster rate. Because see, one thing you should know is, see, and why these particles are in constant motion for liquids and the gases is, see, actually these particles each other, it is held with the, actually there is some force of interaction between these particles. So the interaction between the particles in liquid, okay, so it is actually a little bit stronger than solids. On the other hand, for gases, the interaction between the particles, it is much, for gases, this is in the case of liquids, but for the case of gases, the interaction between these particles, actually there is no interaction, almost no interaction is there. So these particles, it will very freely move. It is not even in random motion. Actually, it will be like, suppose, if I open some gases, it will go, it will automatically expose and it will go everywhere. Okay, so that is the case actually. And now, like we will see some evidence of particles, how we can see, we will see some, there is a presence of particles. for example, let's say Anna, she's cooking in the kitchen. So, whenever she cooks something there, the smell, actually the smell of that tasty food, it will automatically reaches into us. How it is reaching actually? The gases which is producing from that cooking pan, or like from a whatever the food, maybe sometimes she cook chutney, sometimes she cook some other delicious stuffs. So the smell, maybe chicken, or maybe some non-veg items, or maybe sometimes omelette. Actually, the smell from there actually directly reaches into my nostril. Okay, so that shows that some presence of particles are moving from there to here. Okay, and some at least maybe in my childhood and like when there was on the building. Okay, see, like the houses are sometimes mostly with the not concrete houses. Sometimes it is thatched houses. So at least some of you might have seen. See, let's take a house. Okay, so you are okay. This is let it be a bed. You are sleeping. Okay, so let's say it is Adam. So when there is a hole and when there is a sunlight, so if the house is dark, so obviously you can see actually this rays it will be keep on entering. So if you see, if the atmosphere is dark, actually you can see the particles. So the particles you can see. So particles you can see. Okay. So these particles, again it shows, there are on the air there are dusty particles. So mostly what we see is a dusty particles, or maybe some pollen grains, or maybe some water droplets, or like some liquid particles. Okay. So again it shows the presence of particles. So overall what we can say is actually everything around us, it is made with some form of particle. Of course in the later period you will come to know actually what is that particle, and actually what is the what is the name of those particles. Of course we can sometimes call it as molecules, so in the initial phase, and later on actually we can call it as atoms. Okay, so and as the time goes we will see that. So what is the evidence that there are particles in the there are particles actually? So let's see some of the proofs. So this is a reagent bottle, and okay, we will see some experiments, and this is, you can read it. Yeah, this is nothing but methyl orange. Okay, this is nothing but methyl orange. Now if I drop some amount of methyl orange into this beaker, let's see how what will happen. Okay, let me open. Methyl orange, for your knowledge, it is a general indicator actually. It is a coloring substance. It is actually colored. Why it is called methyl? Why it is called methyl orange? Because it appears as a orange color. Okay, and yeah. So I will open, and here I will take here little bit. Okay, I am putting. So you can see. So when it is, you can see how it is spreading, right? Yeah, little bit of methyl orange I put. Initially it was, actually it was very little. Now you can see how it is spreading. So it is actually what will happen when I put the methyl orange particles. Okay, methyl orange particles, what will happen is actually it will try to, it was in the crystal. So it will leave the crystal, and it is mixing with the water. Actually it is mixes with the what to say, it is mixes with like water droplets. It dissolves, so it goes along with the water droplets. Okay, so this is what happens. Actually this is there is a proof that there are particles. There are actually like particles, like it leaves the crystal and it dissolves. Okay, it mixes among the particles. So you can see there is a clear-cut proof that there are particles. Of course, if I dissolve more, like it is even spreading more, right? So you can see. So yeah, this is how the methyl orange is spreading, and you can see the color also. So in all these cases, this particles, it is getting diffused. Actually, like see, for example, if I tell you the case of a balloon, okay, so now think that it is getting tight. Yeah, it is getting tight. Now, due to some reason, maybe I just opened this top. What can happen is actually the gas particles, okay, the gas particles from it. So it will start to go out. Actually, where does the concentration of these gases are high? The concentration of gases are high over here, inside the balloon, right? So it is getting, released from inside it outside. I mean, like where the concentration is high to, the concentration is lower. Okay. So this is the case of actually, this is nothing but diffusion. Diffusion means the particles, okay, particles from here, it is getting diffused from a higher concentrated region to lower concentrated region. Okay. So actually, what are these particles? So, see, I had been telling you what is these particles will be moving, and particles will be moving from here to there, right? So actually, what are these particles? These particles, it is called. It is nothing but we call it as atoms. Atoms, okay. So we call it as atoms. Actually, atoms are nothing but there are many atoms. Actually, we will learn a little more details about the nature of atoms and what is exactly atoms. Actually, for the time being, try to know what is these particles, everything around us. See, let it be this marker, or this be a ring, or say, this spatula. This is nothing but a spatula. Okay, this spatula, or say this this tumbler. Okay, these are all made with atoms. Actually, this is made with iron atom. Okay, iron. Yeah, of course, it is mostly steel, so it is iron, chromium, and maybe nickel. So, and even this what is it? This is water. What is inside this? That is water actually. So this water also, it is made with hydrogen and two atoms actually, hydrogen and oxygen. Okay, generally these particles we can call it as atoms. For example, helium. There are actually monoatomic atoms. Actually, for example, helium and neon. Okay, and there are multiple number of atoms. Actually, there are many atoms are available. Okay, there are multiple number of atoms, helium, neon, and all those things. And of course, not all atoms are actually not always these atoms will be in singular form. Like helium is just one atom, right? Neon again it is one atom. Now like if you happen to see this some atoms, like some atoms actually, sometimes these atoms combines to form molecules. We can say like oxygen and nitrogen, okay, and let it be water. So these are actually molecules. Okay, and sometimes, of course, these particles actually. This I am trying to tell you these particles. It could be atoms. Okay, like when only one here actually two oxygen atoms combine to form oxygen molecule, and here it is actually two nitrogen atoms combine to form nitrogen molecules, and okay, here it is actually oxygen and hydrogen. So two hydrogen atoms plus one oxygen atom, right? 1 plus 2, total three. What to say? Total 3 atoms combine to form water molecules. Okay, so and now sometimes some cases actually, for instance, sodium chloride. Don't think that atoms, the particles will be always in the form of atoms and molecules. Sometimes sodium chloride, NaCl. So it is Na plus plus Cl minus. So this is actually positively charged particles and negatively charged particles. So like this charged steps we call it as ions. Okay, charged particles we call it as ions. Actually, these are nothing but ions. Right? So sometimes like sodium chloride, nothing but the table salt what we see in the kitchen. That is sodium chloride, and let it be potassium nitrate. Hope many of you might be cracking the joke, might be cracking the crackers whenever some festival time comes. So those things actually it is in fact those things are in fact nothing but potassium nitrate. This also containing actually K plus and NN3 minus ions. So sometimes it contains positively and negatively charged ions. Okay. Hi. Now there could be one question like whether there is any possibility to see the atoms by any special instrumentation. Say, once upon a time it was not an easy task. Like even though there were advanced microscopic techniques like scanning electron after that then scanning transmission electron. See, all these microscopic techniques, once it has come, we were able to observe the atoms and ions, and so we were able to observe, see, microorganisms or like we were able to see the things in the 10 raised to 6 scale. 10 raised to 6 it is how much times? Okay, 100, sorry, 10, 100, 1000, 10,000, 1 lakh times, right? And some of the transmission electron microscope and all, it can go up to even even higher end. So more than 10 raised to more than 1 lakh or more than 10 lakh times, you were able to observe the things. Even then, it won't go to the extent of observing atoms, because atoms usually it lies in the 10 raised to minus or 12 range, which is not an easy task by normal microscopies like say whether it is compound microscope, advanced version is scanning electron microscope, even advanced version is transmission electron microscope. Even through that it is not possible. Okay, and but one of the technique which made it possible is transmission scanning tunneling microscopy. This is one of the finest microscopic techniques using which you can observe the observe atoms. Here what I have circled, actually these are two gold atoms, so you can see how the gold it appears, right? And now this is again another picture. This is some platinum atoms. Actually platinum atoms, it is you can see here, right? Actually this is the image of a transmission electron microscopy, how it appears. So we can be happy that it was made possible by the human invention to observe atoms or ions on the surface of certain objects, how the atoms are distributed. Of course, for a schoolish level, it is not, you may not understand the worthiness of this technique, but once we go into some higher research, like how certain atoms are distributed, how certain compounds are distributed, will help a researcher a lot to identify its catalytic, surface, physical properties, or like maybe sometimes magnetic properties and all. Okay, so these we can be proud that human being we have gone to the extent of these are all actually these something what you are observing like a anda means egg. Okay, these are all like it's a very exceptionally outstanding discovery. Nowadays we have even reached the extent of observing atoms through scanning tunneling microscopy. But of course one thing you should know that this STM and all, it is not affordable by even some of the very finest laboratories in the world. It's very costly, by Indian rupee, even a transmission electron microscopy cost more than 4 crore. Okay, it cost more than 4 crore. So this STM, obviously it will cost even more than that. Okay, yeah.